All right, welcome back to our final lecture on classes. We're ready to finish up these slides. So we did a lot last time talking about how to make classes implemented across multiple files, and we talked about getters and setters because we like to use private for a lot of things, including our member variables. We also talked about const. Let's keep going. Let's have an in-depth example first. I think that's a good way to start. So let's recreate our counter library that we did with functions. Remember that? Let's use classes instead. So we'll make like a counter class. That is the idea. So we want to be able to say something like this in our code. Let me make sure we're in the right spot. Yep. So here's what we want to do. We want to write something like make a counter. Counter C semicolon. That makes a new counter object, and you can have multiple of these. We only had one counter that we were keeping track of with our function-based library, didn't we? This is much better than that. Then we can have c.init to initialize it, make the count 0, and then c.inc can increment the count. We can call that as many times as we want. So these are the kinds of operations that we want to be able to do to a counter. Initialize it, reset it to a new count, let's say, increment it, decrement it, and give the count back. That was secretly a getter. You remember that? So that's why I talked about it there. So this will make a counter object called C. That's what we want. We like a counter object now because we're using classes. And we only need one member variable for a counter class. It's just we need to keep track of our current count, right? So that'll go here, start at 0, and once I call inc, it'll make it 1, for example. And yeah, counters themselves now know how to initialize themselves, know how to increment themselves. It's like that's part of the type. So that is the goal, and let me show you how to do this. Let's build up this example, counter library using classes. All right. Vim, let's just do counter.cpp. Let's for now just do it all in one file. So here is what I would like to do. I'd like to make a counter c.init. Always want to initialize our counters, and then we can c.inc it a bunch of times. What other things do we want to do, or want to be able to do? We would like to reset our count in a second, but maybe we should print out the count just to make sure it's 3 right now. So make it, initialize it, inc it a few times, c.getCount, print out the current count. There's also dec, c.dec a couple times, then the count should be 1 now, yeah, after I've decremented it twice. So this should print 3, that should make 1. We can reset a count, c.reset, to anything, any new count that we want to pass along. So maybe we can reset the count to 42, and then the count should just be automatically 42. Of course, normally we would reset it with 0, right? And I think that is everything. So those are some examples of how I want to use this class. Now let's make the class called counter. Okay? It'll keep track of all these, all the data necessary for a counter, which is just the count, and then all the operations that I'd like to perform on that data. So class counter, semicolon, and so I'm going to have some public things and some private things, right? Just one private thing. That is our member variable. So every counter has its own count. And that it's keeping track of that. So I could make a separate counter, call it D, and they could have separate counts that they're keeping track of, just because member variables work like that, right? So let's see if I can painlessly copy and paste this. Not bad. So init is going to be a void method. Just gets called, does nothing. Reset, also a void method. It's going to get called and do something. Sorry, not nothing. Init is going to do something, but not give a value back. Same with reset. It's going to do something. It's going to set our counter. Set the count inside of that counter. So really this is a setter, and that will change things. So that will work like that. Inc also takes no parameters, changes the count. Same with dec. GetCount is the one thing that gives back our current value. It's a getter, and it's actually the only method that doesn't change the counter, right? It's the only thing that doesn't change count. All of these change count. They need to. Get count needs to just give it back. So get count can be a const method, okay? Because it is secretly a getter. So these, I believe, make up the definition of our counter class. I hope that makes sense. So now let's go and increment them, okay? Or not increment, implement. Too many similar words today. So I want to implement all of these methods, and remember they are methods, they're not normal functions. If I try to implement something like this, C++ thinks it's a function, and I have to tell it, no, this is not an init function, it's an init method that belongs to the counter class. It's counters in it, yeah? Same for reset, and inc, and dec, and get count. So let's go and make some space to implement all this stuff, and then we'll do it. So remember, inside of our counter object we have a count, and that will tell us what needs to happen inside of the method. So init just needs to initialize our counter to set its count to 0. Count, similarly, init's supposed to be called just at the beginning of the counter's life, and then reset takes over from there. It sets the count to whatever the user passes along. So it could be new count. Doesn't have to be 0, it could be 42. And then inc is supposed to increment the count inside of the count object. Dec is supposed to decrement the count inside of the count object, and get count has to give back the current count inside of that count object, or counter object. Does that make sense? So that is how all of these methods are getting implemented. Let me put their declaration, or their definitions, just like this, so that you can see them while I work over here. So here's main, here's what main needs to do, and here are the implementations of all of those methods for counters. So let's compile and run. There we go. So we do get our 3. So init makes it 0. 1, 2, 3 init, 3 inks, and then that prints 3, because the count is currently 3, inside of our counter object. Then we have c.dec once more, that'll bring the count down to 1, and then reset just resets the count inside of our C object to whatever we pass along, so we print 42 here. So that is a counter class, and the beauty of it, the thing that's better than our original function-based counter library, is I can have 2 counters, each holding different counts. That's what we can do. So let me teach you a little bit more about how methods get called. I know I drew a picture up here talking about how negate was getting called on points and what it means, like the current object's member variables are visible just at the top level as if they were a normal variable. Let's talk about what's really happening at a bit lower level when you call a method, okay? Secretly, C++ is translating your code. Secretly, methods are just functions. It's crazy. Every method is just a regular function, but it secretly gets a 0th parameter, which is the object itself, okay? So when we call c.inc, secretly, C++ is doing this. It is translating this call to a call to counters inc, and even though we don't give any parameters, secretly, inc takes 1 parameter. It is the current object that we're trying to call inc on. So it's really, C++ is translating these method calls to function calls that look like this. Okay? That's what's happening. And the name of this secret 0th parameter it's called this. If only I could spell this. That's the name of the parameter. It actually exists inside of the method. You can say the word this, and it is a keyword. And we'll talk about that more later when we talk about pointers, but that is how it works. When you make a method call inside of C++, it's translating it into this call, where inc is just a regular function, but it's getting that first thing as a parameter. It's getting that object as a parameter. Okay? So that's what's happening. And so when I call from main c.inc, Here's my counter object. See, it has a count stored inside of it. We initialized it, set to 0, and then I call inc. It's calling inc on our C, right, with a secret parameter called this. So, and that is allowing us to access this object. Okay, so that means that like this is a synonym for C itself inside of the increment method. Okay, so once I'm in here, I can say this, and it really gets me C. So this is not something you have to memorize. We'll talk about this more in depth later. I just want to give you a hint as to why everything works. Okay, so saying count plus plus inside of the increment method, because that's what it's running, right? It's getting translated into a expression involving the this parameter. Okay, that secret parameter. It's really getting translated into this dot count, essentially, plus plus. Okay, because this is a secret parameter that gets the current object. That's its name. And so every time we access the current object, C++ is going through that secret parameter called this. Okay, so it's translating method calls into function calls and accesses of the member variables into indirect accesses of an object's member variables. Okay, so that's secretly what's happening. Feel free to ask me about this more in office hours. There's a lot more to this, but this is what we're ready for right now. Okay, so this is why you can write it kind of like this outside, and it kind of looks like a function, but secretly some special things are happening when we make those method calls. All right, so that's as far as I want to go there. Hopefully I didn't confuse you too much about this. You don't have to, I'm not going to test you on this idea, but it's me trying to prove to you that this is not magic. Okay, there is a reason behind everything. Classes work normally, like we understand C++ to work. So the next thing that I would like to talk about is that init method. I was very careful when we made our counter library, even with functions, to talk about, okay, let's have an init method that we're just going to call once. And even here, let's have an init method that we're just going to call once after the counter begins its life, just to set up everything. That's a nice thing to have a lot of the time, because we want to initialize our objects in a nice special way. So the question is, what if I forget to call init? Like, I know I need to do it, but what if I'm lazy or tired one day and I forget? Well, there is a way to have C++ always call that kind of initialization function or method for you, and it's called a constructor. It gets called when the object is constructed. A constructor is just a special method with a very special name, and it gets called for you whenever you make an object, so it can handle any default kinds of initialization that need to take place, which is super nice. Okay, so if you would like to make your own special always called init method called a constructor, the name of that constructor is actually the name of the class. The name of this initialization method is the same as the name of the class, which is weird to think about. So for a counter class, the name of the constructor is also called counter. So you have this kind of thing going on. Oops. Class counter, and then here is two methods inside of it called counter. There's two. You can have as many different kinds of constructors as you want. Here's a constructor without parameters. We'll talk about this in just a second. Okay, so that's a bit odd, isn't it? But it's useful. So that is what a default initialization method looks like. It's called a constructor, and it always has the same name as your class's name. All right, and just because it's always going to be called for you, and we know it just does something, you don't have to associate a type with it, because it's like always void, right? Or it's always like giving back a counter. It's making the counter for you. So there is no need for a return type in the constructor, because yeah, we're making a counter. I don't have to say counter twice, right? So that is another thing that looks a bit weird when you make a constructor. You don't give any return type, you just say counter and then any parameters that you want to give for the constructor. And also, you can have multiple constructors, because constructors can take parameters. I want to make a counter in a default way, doesn't need any parameters, or I want to make a counter in a special way that takes maybe 2 parameters to set up what needs to go on. Okay? That is how it works, and I promise it's going to make a lot more sense when I give an example. we kind of usually have been using this idea of a default constructor. There is a default one, and that's a constructor that takes no parameters at all. That's the kind that looks like this. A constructor that takes no parameters, that just initializes that object in a very default way. It's called a default constructor. And C++ has been making a default constructor for us secretly that does nothing at all. So we can give our own implementation that actually does something like initialize our count. All right, so let's make a default constructor for counters, and then we'll also make a one parameter constructor for counters as well, and I'll show you the difference and how to use them. Okay, so this will mean that we can get rid of our init method. Now we're going to turn it in to a constructor. The name is going to be counter. This is a default constructor. And let's implement it now. And again, I don't need it in main. Let's just have one window right now. So let's implement this default constructor. Here is how you do it. Again, no return type. I know it looks weird. So the name of this method is counter : counter. It's counter's counter method. This is the constructor's implementation, the default constructor. Here is what we want to have happen whenever a counter gets made with the default constructor. We would like to set the count to 0 so that it's always initialized to a nice value that's not undefined. Okay? So all the default constructor needs to do is set the count to our special default value. And this line, secretly, calls the default constructor. Isn't that nice? So it's going to work. That calls the default constructor, initializes the object's count to 0, and we are off to the races because then the rest of our methods work just fine. So that is the method that we added. And everything works. Our counter's count is being initialized just for free because of our default constructor. This is secretly making the counter C object and also calling the constructor for us, the default constructor for us. Okay? I would also like to make a one parameter constructor and show you how to call that. Okay? Because sometimes maybe we would like to make a counter with a count that starts at some random value, maybe like 42, anything special, doesn't matter. We can make our counters start with a certain value by giving ourselves options in a constructor. So let's make a one parameter constructor that takes a starting count. Okay? And let me show you how to implement it. It, I hope, makes sense how you would go and implement this. You just say, here's the name, counter again, but it takes one parameter, and it sets the count to that. Okay? And now the question is, how do I call this one instead of this one when I make my object? Let me show you. Excuse me. Here's a counter D, and I'd like to use the one parameter constructor, the non-default constructor. And so it's as if you make a method call right as you make the object. You do this. This is the syntax. So I can say 42 here, or 55 here, and that will call the one parameter constructor. It looks a bit odd, I know, but it calls the constructor. So that's how I differentiate. So secretly, this default constructor is being called on this line because it's C++ is kind of doing that for you. It's filling that in. All right, so that's how you call a different constructor, and I've shown you this idea before with vectors. Like if you make a vector of ints v, you can give like a default initial size. That's a constructor call secretly. That's why the syntax makes sense. So d.inc and then cout d.getCount. It'll be 56 because we called that default constructor, or that non-default constructor, that one parameter constructor, to set d's count. Okay, Hopefully that makes enough sense. Please yell at me if it does not. Constructors are very powerful. They help initialize your objects. So this calls the default constructor, this one, and this calls the parameterized constructor, you can say, to set the count to something different. And this is the syntax. After the name of the variable, the name of that object that you're making, you give parentheses, and then you give arguments to the constructor. And that's where it gets called, okay? Right as the object gets made. So that's kind of weird looking syntax in a lot of places, but hopefully you understand the idea, all right? The next topic that I would like to go over are initializer lists. So it's possible that you have a member variable inside of your class, like count is a member variable, but that member variable is itself a class, okay? It is itself like a vector or something. And we would like to construct this class using a different constructor than the default. Do you see where I'm going with this? Like, we want to, at the beginning of this life, the life of this object, this counter object, which itself holds both a count and a vector for some reason, we want to initialize this vector to maybe a size 50 vector right off the bat. We want to call the constructor on the vector as we make our counter object. Okay, do you see what I would like to do here? That needs some extra syntax in order to, inside of a constructor, call the constructor of a member variable as it itself gets made. Okay, that is important because that will help you construct a member variable. Also, if you have a const member variable, const double D. If you have a const member variable, constants need a value in order to exist, right? You cannot set the value of a constant inside of a constructor. It's too late. We need another place to do that, okay? So that's what this thing called initializer list gives us. It gives us a place to construct member variables and also initialize const member variables, okay? You have to use this thing called an initializer list, and I'll show you what it looks like. You give a colon after the parameters of your constructor, if there are any, and then you give a comma-separated list of constructor-style initializations, which is a weird topic that I will go over right now. So let me just show you this syntax right here. This is what's going on. You say, here's my constructor. It can be anything. You don't have to have any arguments at all. But when you want to initialize things, your member variables, you put a colon. This is after the closing parenthesis of your parameters and before the opening brace of your body. You give a colon and then a bunch of these. These are constructor calls, where these first things are member variables and these second things are arguments to their constructors. Okay? It looks really weird, I know, but that is how you do it, and the secret to remember is this sad face right here. Okay? So look for that sad face. That is an initializer list. Whee. And enough talking. Let me show you an example, because like all things in this class, showing an example makes a lot more sense than throwing a lot of words at you. So here are two things. Let's pretend that counters for some reason need a vector and a constant double inside of them. Let me show you how to initialize these things in a certain way. So if I'm using vectors, let me include vector. And here I go. So I am forced to initialize that D everywhere actually right now. It's not even going to compile right now. So here is what I would like to show you. If I don't give an initializer list, V gets default constructed. Which makes an initial empty vector. That's what default constructors do for vectors. The default constructor for V gets called if I don't include V in the initializer list. So I'll show you what that means after I type this. And then D must always be initialized using an initializer list. Okay? So let me show you how to do it. So you have your constructor, and then in between the closing parenthesis and the opening brace, you put a colon. And then you start saying things that look like this. You say, v, here's its constructor call, comma, d, here's its constructor call. Because you can initialize doubles in this way too. This totally works. You say 3.14 or something. Okay? That's how it works. These are initializer lists. So if I want to initialize the count to 0, instead of doing it here in the body, I can do it up here in the initializer list. Make the count start at 0. It's like you're calling the constructor on an int. This is a constructor style initialization. That totally works. Okay? That's how you do it. It's a colon and then a bunch of things that look like constructor calls. Even for normal variables, it works. Okay, so let's do the same for this one. Instead of this line, I'm going to say colon, the count becomes the starting count. Make that constructor call. And then I can just not say anything about v, the default constructor will be called, and I can initialize z to 5.6, or d to 5.67. So by not talking about v here, its default constructor will be called. So yeah, just to show you that this is all happening, like cout, I'm in the default constructor. And we'll print out the values of all our member variables, like print the count, and a space, and v's size, for example, and a space, and d, and a new line. And then this one's the parameterized constructor. Alright, so let's do a split screen again, and let me show you what happens. So this is a constructor call. Before the body of the constructor gets run, before this all happens, it runs the initializer list to initialize things. So this calls the default constructor. So it goes here, initializes count to 0, v to be a size 42 vector, and d to be 3.14. Sorry. And then all of those things have been set by the time we get to the body. 0, 42, 3.14. Cool, huh? And then when we do this one, when we do the parameterized constructor, we go here and we run its initializer list. Sets the count to whatever the starting count was, and d to 5.67. Because I did not mention v, it gets default constructed. So it's empty, size 0, but the rest makes sense. All right, so that's the initializer list. It's just another way to initialize things. This is another option for count, but for some things, like vectors and const member variables, you must use the initializer list to construct them in a non-default way. Okay? So that is the constructor in a nutshell, and initializer lists in a nutshell. Check time, and let's go back to the slide. So, with all of this, it's your turn. I want you to try this. Using initializer lists, please create a constructor for our points that we were talking about last time, so that you can do it like this. Instead of saying p.setx to be 3.5, p.sety to 4.7, make it happen right off the bat. Declare a constructor and implement it too for points that takes those two things to set into x and y. Okay? And I want you to get practice using initializer lists to do it. Okay? So if you remember the declaration of the class point, what needs to change? So in the public place, we need to add, we already have like private double x. Let me indent. We have double x and y, those exist. And so I'm about to add stuff. Let me add the things in green. There's already plenty of other methods and things, but we're going to add a constructor. The name is going to be point this time, right? Because the name of the class is point. It's always the same name as your class. And then it's going to take two parameters, one for each thing that you want to set. So double, let's call it like xval, and double yval. That's the declaration of that parameterized constructor. And so you're able to initialize the point to something that you pass along. Sorry, I keep losing my voice today. That is unfortunate. So that's how you can call it now once you have this constructor. And here's how you'll implement it. You'll say point, : point, again, no return type. And you give everything as before, double xval, double yval. And then you put a colon to begin that initializer list. So I definitely didn't give myself enough room here. I'm trying to get that last parenthesis and it's not coming. There it goes. So here's what you do. You say : or sorry, just one colon. I'm too happy about the colons. So you say one colon, and then you give a bunch of constructor calls to the things that you want to set to your member variables. So x, please set that to xval. Y, please set that to yval, that parameter that was passed along. And actually, because of that, that's everything that you wanted to do. You can totally have an empty body now. Nothing needs to happen in the body because all that initialization is happening in the initializer list. Okay? So isn't that neat? That is how you can do it. So that is how you can make a constructor for points that works like this, so that you don't have to separately make method calls to set x and set y, which saves us a lot of time. That's quite nice. So with that, I talked about a lot of colons today. Here's one colon, and then we use those two colons starting last time. Let's talk about : because that's a very powerful thing. We talked about it even on the first day of class. Remember that? I had to say standard : cout first before I used namespace standard. So let's talk about, like, where is all this coming from? What are namespaces? Why do I use that keyword when I make my C++ files? And then what does : really mean? It's called the scope resolution operator in full. Okay? So let me talk to you about this. Every class that you make gets its own what's called namespace. Okay? So that means counter has its own namespace, and it has things inside of it that are defined, like it has a count, it has an inc method. All right? And if I were to make another class, maybe like counter2, a slightly different implementation of a counter class, call it counter2, that can itself have its own things with similar names. Counter2 can have its own count and its own inc, and there's not a problem because they're in separate namespaces. Okay? That's the idea there. And if you would like to access elements of a namespace, you use : to say which one you're talking about. Like, I want to implement the count or the inc method for the counter class, or I want to implement, no, the inc method for the counter2 class this time. That's how you can differentiate. You use those : that's called the scope resolution operator. So technically, if you're not working in namespace standard, everything in the standard library is inside of a namespace called standard, std. You can make your own cout, can't you? You can make your own cout that has nothing to do with standard : cout. Isn't that nice? You can make that inside of your own namespace. So this is more general than just classes. You can make namespaces for anything, to hold anything. Namespaces are used when you want to have two things with the same name. So these examples make a lot of sense, I hope. And not have the names clash, to have them both coexist. So let me show you an example of this where I make two separate functions, both called blah, and two separate global variables called x, but they're inside of different things called namespaces. All right? You don't have to make a class to make a namespace. Let me show you how to make your own, and then finally this bullet will make sense. Then I'll be ready to talk about that. So let me make a new file called namespaces.cpp. Yeah. So here is what you can do. You can make your own namespace. You just say this, namespace, and give it a name. I don't know. What do I want to call it? I'll call it N1. All right. So that's a namespace. I can put stuff inside of it. And here's a namespace N2. I can put stuff inside of it. And they can each have the following. Let's make two functions called blah. So here's a function called blah that returns an int. Here's another function called blah that returns an int that is 55. So you could totally not do this outside of the namespaces, right? They cannot clash like this. This is not allowed. But inside of separate namespaces, it's okay. And then let's make two global variables called x. So int x equals 5 and int x equals 7. So what this syntax does is it makes a brand new thing called a namespace, a new cloud that holds definitions and variables and whatever you want to hold, and it kind of sections it off from the world. All right, here's another namespace that holds all of these things with similar names. And then down here in main, I can access each of them. I can't say blah anymore. I can't like cout blah, cout x. I have to say which blah, which x, inside of which namespace. I have to use the scope resolution operator. So if I want to call n1's blah, well, I definitely have to do that. I can do it like this, n1 : blah. That gets at that one. This gets at n1's x, that specific global variable called x. I can do the same for n2. And there's C++ has no trouble having both of them exist now, because I have qualified them with names inside of their namespaces. Okay? Look at that. So here's me getting at n1's stuff defined in its namespace. Here's me getting at n2's stuff defined in its namespace. Let me compile and run this now. Yay, so it's going to get at those things, 42 and 5, 55 and 7. I hope that makes enough sense. So that's secretly where all this is coming from, and so like everything in the standard library is defined inside of this syntax. Like if you look at the implementation for the IOStream library, or for the vector library, they put all their stuff inside of here. That's how the standard library gets made, okay? And so that's what using allows you to do it. It allows you to import everything from a certain namespace so that you don't have to qualify it. All right, so one less magical piece of syntax now. Now we know exactly what that means and does. Okay. So the very last topic for the day is called operator overloading, because sometimes we would like to use normal mathematical operators on the classes that we make for ourselves. So for example, maybe I'd like to add counters together or add points together. I'd like to say something like C1 plus C2, even though C1 and C2 are like counter objects. They're not numbers. I can make an implementation for plus, in fact, and that will just get translated into something special and work. Won't that be so cool? I can define what plus means for my classes. I can define what minus means for my classes. It's called operator overloading. I'm overloading what that operator means for my specific purpose. All right? So let me show you the secrets, and then we'll get into the details. So secretly, when you have two objects that are counters, for example, C++ tries to translate this code, C1 plus C2, into either this, C1 dot, the name of plus is operator plus secretly, translates it into C1 dot operator plus C2, or if that one doesn't exist, it looks for a function called operator plus that takes two things, right? Because you need both at that point. It either tries to call this method, C1 dot operator plus on C2, or just operator plus function on C1 and C2. Whichever one exists, C++ will find and use. All right? That's the goal. That's what secretly happens. And that means then if we want C++ to be able to add counters using the plus operator, then we just have to implement either an operator plus method or an operator plus function. Isn't that cool? So the goal is to have something like this. I have two counter objects, C1 and C2. and then I do like, they both have a count, right? Maybe it's like 2 and 3. I would like to make a counter sum equals C1 plus C2, and it will fill in that sum with this, a count of 5. That's what I'd like to do, and so this is going to get translated into either one of these, and we can pick which one we would like to implement. Are we ready? Let's give this a try. Back to the code we go. So, well, let me close out my email, sorry. Let's go back to counters. So here's the kind of thing that I want to be able to do. I'd like to make 2 counters, or I have already made 2 counters. I'd like to sum them now. I'd like to be saying something like this. Counter sum equals, I guess, C plus D in our case. And that means I need an operator plus method or function. And then I want to be able to see out sum.getCount as well. So let's work on this. So again, in order for this to work, C++ is going to look for one of these. It's going to look for either a method called operator plus or a function called operator plus. All right, so let's try to do maybe the method. Let's do the method way for plus. So it's going to look like this. Operator plus needs to give back the sum, right? What is the sum but another counter? So that's the return type. It's another counter called operator plus, and we're adding ourselves, because it's a method, to some other counter. And usually we take it by constant reference. Const counter reference. I'll call it other. So that is the addition operator on counters. Isn't that cool? And C++ will find it and call it when I say C plus D. This will get translated into C.operator plus with D. Okay? So then I want to implement this. I'll do it down here. Oops. So this is how it will work. I will do, I'll declare a new counter, counter res for result or something, and I'm going to return it. And let's get practice with actual, like, constructor calls, because I have a way to set the count of a counter in its constructor. So let's use that on res. What should its count be? Well, it's our current count of the current object, and then plus the count of this other thing I'm trying to add to it. See how that will set the count? Isn't that neat? So that should be happy, and it's currently underlining it for me because it's not fully qualified. This is counters operator plus method. Yay. And so that should work. I think I'll have to split screen again to get it all in view. And here we go. So it looks like, what was it, 55 plus 42, oh, decremented, 54 plus 42. It looks like it is 98 somehow, for some reason. I can't remember if that is correct. 90 something, 97? Oh, 98, yeah, because I incremented it, not decremented it. Okay, that is in fact correct. Yay. And that was another parameterized constructor call. What do you know? So it's 98, and that is our answer there. So that was for that plus operator. I can do the other way too. Why not? Let's do that other option. So either this way works, and I'll comment this one out, or C++ also will look for a function to add things. Option 1. C++ would also look for this one. Counter operator plus is the name of the function, and then it's going to take 2 counters now, because it's just a function. It needs to know each of them. C1 const counter reference C2, and then it's going to go and add them. We can do the same thing. So it's C1.count and C2.count now. So this is another option. Still works just fine. But sadly, I can't get the count anymore because this is a private thing. This is just a normal function at this point. I have to say get count here. I cannot access the member variables, can I? Good old access control. So it's still going to work. Still 98. Okay. So that's the other option. Option 2. C++ will look for either one. And let's keep this one, this original one, working. Okay. Translated into either C.operator plus D or operator plus C and D. C++ will try both, find one that works. You only need one of the two. So that's plus operators. You can now implement any kind of other operations, right? There are plenty, and I encourage you to look them all up. There's operator star, operator less than. You can even like figure out how to give something to cout. Just give the object straight to cout with the operator left arrow, less than, right? Operator plus plus. What does it mean to plus plus a counter? Interesting. Let me show you some of these. So let's make, instead of using inc, let's have another option. Let's have the ability to do plus plus on our counters too. Wouldn't that be neat? So let's implement the plus plus operator for counters. And here's what it looks like. I'll do it up here. It has to be a member function. Void operator plus plus takes no parameters, because here's what's going to happen. I'm going to say it down here. I'll be able to do this, I think. Let's say sum, and for reasons, it's the prefix plus plus operator. You can look at the documentation page to see how to do the other one, but this is 1 at least, and so that should increment whatever sum's count is. It's just another way of calling the inc method in a sense. And so let's be cool people and implement this outside the class, but this is what it's going to look like. Operator plus plus, and here is us implementing it right here. It's operator plus plus for counters, and what it's going to do is increment the count. Another option instead of doing the inc call. Okay, so this is getting translated into sum dot operator plus plus secretly. And so it's another way of doing inc. I can replace other calls as well. So it was plus plus d instead of d.inc. Instead of c.inc, I could do plus plus c. I have options now. So that's the code. Here is the implementation, and let's watch it work. Should get the same answers back. And so I ran it once, and now 98 became 99. Operator plus plus. It's secretly being expanded to this. Okay? That's how that works. And so there's a ton of these. There's a ton of these operator plus plus. There's more. You can look on this page for more. All of these exist. Ampersand, plus equals, minus minus. All this stuff is possible to be overloaded, and there's a ton of little examples here as well. So give that a look. Let me do one more for us, and that'll be it for the day. Let's pretend that we would like to sort vectors of counters, because why not? We totally can. All that C++ needs in order to sort something is an operator less than. What does it mean when something's smaller than something else? Because then it can order things based on that operation. Yeah, we need to be able to tell it, what does it mean when one counter is smaller than the other? When is that true? When is that false? As long as we have that, we can order counters. Won't that be neat? So let's do that. That can be our last example. I already have vectors included. Cool. Here is the idea. Let's make a vector of counters. Okay? Vector of counters, because why not? I'll call it VC. And here are a bunch of counters. I guess I can call the constructor a bunch of times. That could work. Or I could put C and D and sum into it. And I think they're already in order, so let's go backwards. Sum, C, and D. Something like that. Let's get them out of order. Maybe D's bigger, right? Let's do it in that order. So there's a vector of counters, because we can do that. And then let's try and sort that. Algorithm. Sort vc.begin, vc.end, and that's that. This is not yet going to compile because there is no sort possible for counters right now. It's going to have a bunch of long undefined errors, but at the very top it's going to be like, I don't know, operator less than for counters. That's what it needs in order to sort. So, because it's looking for that, we can implement it. Okay? Let's do an operator less than outside of the class. Operator less than on counters. So const counter C1. Let's make a const reference. Const counter reference C2. And this needs to return a bool. Okay? This needs to return a bool, and let's have just one window right now. So when is it true that C1 is less than C2? Because it's going to be called like this. C++ is trying to check C1, is it less than C2, so that it can sort it. And that's getting translated into C1 operator less than called with C1 and C2 when it's outside of a class. Okay? So let us compare based on counts. Return whether or not C1's count is smaller than C2's count. That's kind of logical, right? So if you do that, then it can be sorted based on smaller counts first. Okay? So that's a comparison. So now we can loop through this, like for every counter called CTR in VC, let's go through it and see out whether or not we found the right thing there. So let's output the get count for that counter to make sure that it actually got into sorted order. See out new line, and this should all work. Sadly, the reason I stopped the video and started again is because there is a silly little error involving sort because we had a silly example of a const member variable. Okay, so let me get rid of these extra member variables. Okay, let's get rid of V and D now. They no longer exist. Whee. So we're actually doing only counter stuff now for once. And that's going to mess up some stuff down here too, because I was outputting, was it in the constructors, those things? So let's just remove that too. And now it should successfully compile and be happy and actually sort the stuff. So, oh man, all my counters that I put into this vector of counters are in sorted order depending on their count. Isn't that cool? So that was because we implemented operator less than, what it means for one counter to come before another, and that's all sorting cares about when it's trying to reorder those things. Okay? So that is operator overloading. That's the last topic for the day, and this means now that we're done with the classes slides that I can release your next lab. So go and watch the lab video now, and I will see you there and then after that in the next lecture. Okay?